In the last video, I showed how to build the structure of the conveyor belt. In this video, I'll show how to add joints, actuators, and constraints to the structure to ensure the correct motion of the conveyor. Now we have something that looks like a conveyor belt. The next step is to add joints. We'll make both rollers have a revolute or hinge joint, which is the default type. For rollers 1 and 2, we'll create joints named roller 1 and roller 2 respectively, with a joint type of hinge. Next, we reload the model and visualize it. To test the joint, double-click the body, then press Ctrl plus Shift and right-click to apply a force to the roller. Although the rotation isn't clearly visible, you can observe changes in the joint values on the right side of the MuJoCo GUI. To make the rotation more noticeable, I'll add a geometry of type box with a size of 0.06 meter x 0.06 meter x 0.001 meter at the ends of the rollers. Since the box needs to be at the end, the position parameter should be 0 on the x and y axis and 0.301 meter on the z-axis, which is half the roller's length plus half the box's thickness. Now we reload and visualize again, and there it is. We can now clearly see the rotation when a force is applied. As you can see, the rollers seem to rotate without friction. To make the behavior more realistic, I'll add some damping to the joints by including a damping parameter with a value of 0.01. Let's reload and check. Now we have better behavior. Next, since the rollers are coupled by the belt in a real conveyor, meaning when one rotates, the other does too, assuming no slip. We'll mimic this behavior by adding an equality constraint between the two joints. To do this, we add an equality tag with a joint subtag. The joint 1 and joint 2 parameters will reference the joints of roller 1 and roller 2, respectively. Let's check that out. It works just as expected. Now we're going to add velocity control using an actuator, which lets us set the speed of the roller. We'll add a velocity actuator and specify the joint to be controlled. Since the two rollers are constrained to move together, we'll only add an actuator to roller 1. For clarity, I'll also give the actuator a name. Let's visualize and see. We open the control panel and see our actuator listed. By adjusting the slider, we can set the actuator's value. Currently, the control range is from -1 to 1, which is quite small. We'll increase it by adding a control parameter of -2020. Okay, next let's move to the C program that will control this. In my previous video on installing MuJoCo on Windows, linked on screen and in the description, I showed how to set this up. If you followed that, there's a sample file called basic.cc. I'll copy its contents and paste them into a new file called main.c. In that previous video, I also showed how to add a makefile to build the program. I'll reuse that same makefile for this video and the rest of the videos in this series. This program requires passing the model.xml file as a command line argument, but I'd like it to just load the file automatically when double-clicked. So I'll make a few changes, some already shown in the previous video, to accomplish that. After making the changes, open the MSYS terminal, navigate to the project directory, and run make to compile the source code. The compiled program is named belt.exe as specified in the make file. When I run the program, it loads and displays the model, just like this. We can access actuators and code through the control field in the MJ data structure. This field is an array with inputs for all actuators in the model. Since we currently have only one actuator, its input will be at index 0. So now we set the actuator input to 1, compile, and run the program. We can see both rollers rotating at a speed of 1 radian per second. With this part working, I'll add one more object to the model to serve as an item on the conveyor belt. I'll add a new world body with a body tag and a geometry of type box size 0.05 meter x 0.05 meter x 0.05 meter. I'll position the box at a height of 1 m so that it falls onto the conveyor at startup. Now we reload and visualize. We can see the box above, but it isn't falling. That's because it has no joint. We'll add a special joint of type free, which provides all 6 degrees of freedom, allowing the object to move freely. Reload again. Now we see the box fall onto the belt. But when we set the velocity actuator to a non-zero value, the rollers move, but the box doesn't. That will be the task for the next and final video. We'll add sensors and logic to make the object move in sync with the rollers. See you in the next video.